Welcome everyone. Today we are going to look at gravity relationships. So we're going to get into some nitty-gritty. So, have you ever thought about why the planets orbit the sun in the way they do? Why does the moon go around us like it does? And why does the Earth go around the sun the way it does, or Mars, or Venus, or any of them? That's quite a mind-blowing concept because we know how they work. We can predict how they go around the sun. It's all about Newton's law of universal gravitation. That's all about how the forces between all these bodies interact. It's actually quite exciting. So, we know Newton's law. We're going to look at the equation a little bit more, and G and big G, and some graphs, and then we're going to do questions. So, here are our keywords. Newton's law of universal gravitation, which hopefully you can state. Acceleration due to gravity, which you should also know about. And then we're going to look at directly proportional and inversely proportional, and what that means for us. So, if we go back to the equation, we have looked at the equation previously, but what I need you to see here is that when I look at the relationship from the equation, we get the equation from the fact that force is directly proportional to m1 and m2 multiplied together, and we can include the constant in that, and it's also inversely proportional to 1 over r squared. Remember that when we want an inverse proportionality, so if we want to show that something is inverse, we put 1 over. And that tells me that when the one thing increases, the other thing decreases. Okay? That we've done lots, so we're not going to worry about that. Then, so we're going to look at the difference between little g and big G, which we know a little bit about. We're just going to add a bit to it. So big G is the universal gravitational constant, and remember that's the same everywhere. And of course we know that its value, let's just write the value in. I'm not going to include the units, but its value is 6,67 times 10 to the minus 11. We don't have to learn that because it's on our information sheet. Then we've got acceleration due to gravity, which of course is an acceleration. And that changes from planet to planet, and it depends on the planet. What we're going to do is we're going to go, how do I know what G is? And I'm going to show you later on how we know what the equation is and why all of a sudden there's an M missing. But that's very important. We then get to our graphs. And graphs become one of those sections where you get asked it a lot in different pieces of sections along the way. But the basic principles about the type and the shape of the graphs is very important because it follows the same, whether it's a directly proportional graph or an inversely proportional graph. So when we look at the graphs, we have two. We're going to have the graph where f is directly proportional to m, and that means we're going to get a straight line where this is m1, m2, and that's f. When we look at the inverse proportion, what happens here is we're going to end up having to get a graph where we've got 1 over r, and it does that. But we don't get there straight away. There's a way round to get to that inverse proportion. Directly proportional, those are fairly simple, and it's easy to get our head wrapped around it. The inverse proportion, sometimes the wheels fall off a little bit because it feels weird, okay? But I'm going to show you that, so we're going to hang in there. Then we need to look at the type of questions we can get, and this is quite important because there are two types of questions. We get substitution questions, which are the nice ones, where they give you values, and you just substitute it into the equation, and off we go, we get an answer. Whether that's because I'm looking for force, or whether I'm looking for R, or whether I'm looking for M, it's nice. We've got values, we substitute them in. Sometimes, with substitution questions, they may end up also being simultaneous equations. Those aren't so nice, but that's just a maths issue, but they're still substitution type questions. The last type we get are the ratio questions, and these are the ones we tend to struggle a little bit more with, because these are the questions where they go, if I double this, what happens to that? And now they don't want us to do a calculation, or they don't even give us values. So they'll tell you that you have a planet that is 3 times the mass of Earth and twice its radius. What would the force be that something will experience? And you're like, I don't know the mass of the Earth or the radius of the Earth, so they're not substitution questions. They have to use a ratio, and I'm hoping that I'm going to be able to show you a trick to those, okay? But don't stress about it. With regards to the mass of the Earth and the radius of the Earth, they're on your information sheet. I don't know what they are off the top of my head. They're on your information sheet, so don't stress about those. 2 types of questions, really not as bad as it sounds, okay? So, we're going to take a short break, and I'll see you in a couple of minutes.